In this mini clip, we're going to be discussing trigonometry on a unit circle. While we answer this question together, you'll be solving the similar problem on your own using the same technique. We are asked to simplify sine of 25 pi over 3. We're going to solve this question by graphing our terminal arm on the quadrant plane. So let's first draw out our quadrant plane. Next, we need to determine in which quadrant our terminal arm will be found. To do this, we need to find how many times this angle, 25 pi over 3, completes a full circle, or a rotation of 2 pi. In other words, how many times does 2 pi divide evenly into 25 pi over 3? So what we're going to do is we're going to take our angle, 25 pi over 3, and we're going to divide this by 2 pi. This will tell us how many times it's going to rotate fully. Because we're dividing by fractions, we're going to have 25 pi over 3. We're going to change this to multiplication, and we're going to take the reciprocal of 2 pi, which will be 1 over 2 pi. Multiplying fractions, we're just going to multiply across. 25 pi times 1 is 25 pi, all over 3 times 2 pi, which is 6 pi. Now our pi's divide out to 1, so we're left with 25 over 6. And we know that 25 divided by 6 is approximately 4. It'll be 4 in a little bit. So we know that there's 4 complete circles that are going to have to be drawn on our quadrant plane here. So we always start on this axis. Start right here, and because our angle is positive, we're going to rotate in the counterclockwise direction. So we're going to start here. We're going to rotate one full circle, a second time, a third time, and a fourth time. Now we know it's at least 4 circles, and it's going to be a little bit more. But how much more? To find out the remaining angle, we're going to have to subtract 4 times 2 pi, which will give us this complete rotation, by 25 pi over 3. So we have 25 pi over 3 minus this angle is 4 times 2 pi, which is 8 pi. To write this as a fraction, we can put it over 1. Subtracting fractions, we need to have a common denominator, which in our case will be 3. So we will have 25 pi over 3 minus, to get 3 as a denominator in our second fraction, we need to multiply the top and bottom by 3. So we will have 24 pi all over 3. Now we're just going to subtract our numerators. 25 pi minus 24 pi is pi, and we leave the denominator over 3. So the remaining angle will be something similar to this, pi by 3. And then we're going to draw our terminal arm here. Here's our terminal arm, and we know the angle from here to here is going to be pi over 3. I would now like you to draw the terminal arm in the question you are given. Here's the answer you should have got. Now coming back to our question, We just found that pi over 3 will be found in the first quadrant. From this terminal arm, we're now going to draw a right-angled triangle along the x-axis. So here we have a right-angled triangle. Because this angle is pi over 3, you should be familiar with this triangle because it is one of our special triangles. This is something we just need to memorize. This angle is pi over 3, this angle is 90, so this angle in here must be pi over 6. And this is this angle. We know the hypotenuse, this side, will be 2. We know this side will be square root 3. And this side here along the x-axis will be 1. Again, this is just something that we need to memorize. I would now like you to draw and fill in the right angle triangle in the question you are given. Here's the answer you should have got. Now coming back to our question, we can begin to solve our answer. Instead of finding sine of 25 pi over 3, we're going to ignore the full rotations of 2 pi, and we're just going to consider this angle, pi over 3. So we're really trying to find sine of pi over 3. To find the trigonometric ratio for sine pi over 3, there are two things that we need to remember: SOHCAHTOA and our cast rule. According to SOHCAHTOA, sine of an angle is equal to opposite over hypotenuse. In our case, we have sine pi over 3 that is going to be equal to opposite all over hypotenuse. In case you forgot the SOHCAHTOA rule, I'm going to write it up here just to refresh your memory. The S here stands for sine, and when we have sine, we have the opposite, O, over hypotenuse, the H. Now looking at our triangle, the opposite side of the angle pi over 3 is square root 3. So I'm going to replace our numerator with this number. So this is going to equal square root of 3. The hypotenuse of the right angle triangle is 2. So this will be our denominator. Lastly, we need to consider the cast rule. Cast, C-A-S-T. Since we are in the first quadrant where we have an A, this means that all of our trigonometric ratios are positive, which in our case is already true. We have the positive square root of 3 over 2. So this is our final answer. I would now like you to finish off the question that you were working on. And this should be your final answer.